Okay guys, welcome back to my channel. Let's take a look at this next example again on surface areas and volume of solid shape. So here we have a solid below, which is a cylinder surmounted by a hemispherical bowl. We have to calculate a total surface area and also the volume. So I'm going to start my solution right from here to show how to solve this. Okay, we have, this is a composite shape, a combination of two different shapes. The first one is a cylinder and the other one is actually a hemisphere. So if I want to find the total surface area, TSA, the total surface area of this shape is going to be the addition of the surface area of hemisphere, plus the curved surface area of the cylinder, okay, plus the area of a circle. Now, you will be wondering, why do I have this to be my total surface area? The reason is simply because the surfaces that you can account for this solid, number one, you can account for the surface of the hemisphere, that is one. Number two, you can account for the curved surface of the cylinder. And number three, you can account for the circular base of the cylinder. Now take note, be careful, take note that this circular part of the cylinder, the one I'm shading right now, that circular part, you cannot see it because it is inside, okay, the solid. You can't see that part. So you cannot account for that surface. So the three surfaces you can account for in this shape is the surface of the hemisphere, the curved surface of the cylinder, and the circular base, okay, of the cylinder. That's all. All right, I believe you understand that. So if we want to quickly account for the formulas that we need to use, of course, the surface area of a hemisphere, check your formulas, is 2 pi r squared. The curved surface area of a cylinder is 2 pi rh, while the area of a circle is pi r squared. So this is how we get our total surface area. And that is the beginning of the solution of question A. To find the surface area of hemisphere, we need the radius. To find the curved surface area of the cylinder, we need the radius. And to find the area of the circular base, we need the radius. Now let's come back to the diagram. When you have a hemisphere, you will realize that from the center to the circumference, I can also do this. From the center to the circumference, any point on the surface of the hemisphere is actually the radius. You have to understand that. So from that same center to this point here is also the radius of the hemisphere. So that means that we've been given this 7 centimeters here, which then means that this is 7 centimeters over here. as the radius of the hemisphere. Likewise, the radius of the cylinder would therefore also be 7 centimeters as well. 7 centimeters as well. So please take note of that, guys. Take note of that. Of course, we know that the height of the cylinder is definitely 10 centimeters. So the key here is many of us might not realize that the 7 centimeters that was given here is actually the radius of the hemisphere and also the radius of the cylinder. All right, so that being said, we can then quickly solve the problem. So then we have this to be equal to, you can solve it one by one, or you can just kind of factorize to make it easier. If you factorize, you are going to have 2, okay, 2 is not common to all of them. You have pi common, you have r common. So I can bring pi r out, open a bracket. This will remain 2r, okay, plus this will remain 2h, plus, and then this will remain just 1r. Or you could just solve it straight without factorizing, not a problem. So taking pi to be 22/7, and then multiplying this by the radius, known as 7 centimeters now, open a bracket, of course it's multiplying it. 2 times radius is 2 times 7 over here, plus 2 times height, which is height of the cylinder now, that is 10 centimeters, and then plus the radius on its own, which is 7 centimeters again. So solving through, the 7 here, and cancel the 7 here. So I'm left with 22 outside the bracket, open a bracket. 2 times 7 is 14, 2 times 10 is 20, and then plus 7. So here we have 22 times the addition of 14 plus 20 plus 7, that is going to give you 34 plus 7, and 34 plus 7 should give you 41. So when you multiply that together, you should get your answer to be 902 centimeters squared. 902 centimeters squared. So 902 centimeters squared. That should be your final answer for the area, or for the total surface area of this solid. So that is how that goes, guys. All right, let's move on to the B part of the question very quickly. The B part of the question, very quickly, we have to find the volume of this same shape. Now the volume of this solid is definitely going to be equal to the volume of hemisphere, and of course, plus the volume of cylinder. So recalling your formulas, your volume formulas very quickly, you can recall that the volume of the hemisphere is given as 2/3 pi r cubed. Remember in previous lessons, we discussed that that is simply just half of the volume of a sphere. And then I have plus the volume of a cylinder, which is pi r squared h. If I factorize again, what is common over here? I have pi r squared to be common. And then I open a bracket, I should have 2/3 r remaining here. And then over here, I should have h remaining here. So 22/7 multiplied by 7 squared into the bracket of 2/3 times 7, which is the radius, and then plus the height, which is 10. So that would therefore give me 22, because this 7 will take care of one of the 7s to remain just one 7 from the square. So 22 times 7, and then into the bracket of 14/3, that is 2 times 7, 14, then over 3, then plus 10. Okay? So if we continue and we solve this properly, we're going to end up getting our final answer for that to be 2,258.7 centimeter cubed, which gives a final answer of, well, if you try to approximate, you can have 2260 centimeter cubed. This has been done to 3 significant figures. All right, guys, so that is the answer for the second part of this question. Really interesting. Okay, I believe you understand. And you can also join me again in my next video for the next example. All right, see you there.